Hello, 5th graders. This is Mrs. Salyer from Roosevelt. Mr. Foster from Johnson just talked to you and introduced a task called batting averages. I am now getting ready to discuss the solution paths to the batting averages task with you. Remember that this is task 4 in a series of tasks about decimals. So let's first reread what the task was asking you to do. It is, of course, task 3, batting averages. Sam and Nikki are having a discussion about their favorite baseball players. Sam incorrectly says that his favorite player's batting average of 293 thousandths is greater than Nikki's favorite player's batting average of 34 hundredths. Your task was to think about A and explain why Sam's statement is incorrect. Then B, write a correct inequality for the two batting averages using the symbols less than, greater than, or equal to. And C, if a baseball announcer wants to read these averages using correct mathematical language, how would he say them? We're first going to discuss part A and look at 3 students' solution paths to finding out the answer. This is one student's solution path. They used a place value chart strategy, and this is what I recommend that my students use and what I think is easier. You line both decimals up by writing them vertically, one on top of another, and then you go from left to right looking at the place values. When I look at the ones place, that doesn't really tell me anything because the value is 0 for both. So now I'm going to go over and look at the tenths place, and I see a value of 2 and a value of 3. Of course, we know that 3 is greater than 2, so that means that 34 hundredths has the greater value than 293 thousandths, even though this number has more digits. Some students would mistakenly think that 293 thousandths has a greater value simply because it has more digits, but that doesn't work with decimals. You have to look at the value in the place values. This is what another student chose to do. They wanted to use a base 10 block strategy, and what they were thinking about in this strategy is that you took the whole large cube and counted it as one whole. The flat would be 1/10 because it would take 10 flats to make the one whole. The rod would be 1/100th because it would take 100 rods to make the one whole. And the unit cube here would be 1,000th because it would take 1,000 of them to make the one whole. So if you were building this number using the base 10 blocks, you would have 2 flats, 2 tenths, you would have 9 rods, and you would have 3 unit cubes. If you were building 34 hundredths, you would have 3 flats for the 3 tenths, and obviously you can see by looking at the base 10 blocks that there are more tenths, flats, in 34 hundredths than in 293 thousandths. Therefore, once again proving that 34 hundredths is greater than 293 thousandths. Here's another student's solution path. What this student did was think about money, and this is what they've written. I pretended that the thousandths place wasn't there in 293 thousandths, and then thought about money. I know that 29 cents is less than 34 cents. So as we go on down and look at part B, when you were to write an equation, this student wrote that 293 thousandths is less than 34 hundredths, using the less than symbol. Remember that the open mouth is always eating the larger number. And if a baseball announcer wanted to read these averages, you would have to know how to both say and write the words in word form. So, decimals have a first name. The first name is just the number. The last name is the name of the last place value spot. So, we would read the number first, which is simply 293. That's its first name. Now we have to look at the last place value spot, which is the 3, and that's the thousands. So we would read and say that number as 293 thousandths. When we look at this decimal number, we're going to say its first name, which is simply the number 34. Now we have to find its last name, which is the place value of the last digit, and that's in the hundredths place. So we would read, write, and say this number as 34 hundredths.